Hello everyone, welcome to Coders Camp. And we have been seeing the problems that can be solved using binary search. In our previous video, we have seen how binary search works and one medium problem that can be solved using binary search logic. And today we are going to see another problem, which is a hard problem in lead code, that is split array largest sum using binary search. And the problem statement says we are given an array nums which consists of non-negative integers and an integer m. You can split the array into m non-empty continuous subarrays and write an algorithm to minimize the largest sum among these m subarrays. And the first clue we can see here is minimize the largest sum. When you see minimize and maximize, smallest and largest, minimum and maximum in the same problem, then obviously we can solve that using binary search. So we are given an input of an integer array and an integer m, and we have to return the minimized largest sum of subarrays. So let's understand this problem with an example. Here is our given integer array nums, and we can split this array into two subarrays. So let's start splitting the array. So you can split this array as 7, 2, 5, 10, 8. As you can split that as a continuous subarray, so you cannot mix the numbers, and the other way can be 7, 2 and 5, 10, 8. Further, you can split this as 7, 2, 5 and 10, 8, and the last way you can split this as 7, 2, 5, 10 and finally 8. So if you calculate the sum of these subarrays, they'll become 7, 25. The second split is going to be 9, 23, and the third split is 14, 18, and the fourth split is 24, 8. So out of this, the maximum is going to be 25, 23, 18, and 24. So if you see, 18 is the smallest or minimal largest sum of the given subarrays. So now this is the actual split we are going to make, and 18 is the output we are going to return. So how are we going to approach this problem using binary search? So logically, if you think of this problem, the minimal maximum sum is going to be 10. That is the highest value in the given array. M can be any number, that is you can split this array any number of times, but the minimum largest sum you're gonna get is 10. Because you cannot split 10 into separate numbers, 10 can be a number in either of the split, whether it is a separate split or can be in the first subarray or second subarray or in any subarray, but it is going to give a sum which is going to make the overall sum to be 10 or more than 10. So in this case, our minimum value or minimum output is going to be start from 10, and if you add all the elements in one subarray, the sum is going to be 32. So we clearly found our output is going to be between 10 and 32. That is the largest sum given in the array to the sum of the whole array. So now, as we saw in our previous problem, we approached the problem in the same technique. Again, we are going to implement the problem using the same technique. That is, as we have found some limit, that is upper and lower bound, we definitely know this can be solved using binary search. So now this is our lower bound or left value, and this is our upper bound or right value, and we clearly know our output lies between these values. So we are going to take a random mid and check whether this subarray can be split m times within this sum, considering our mid value as sum. If that can be done, then we are going to fix our search of output from lower bound to mid. If not, we are going to fix our search from upper bound to mid to upper bound. So by using this, we are going to solve this problem using binary search. So let's go for a dry run before we are going to the code. So now let's take the lower bound as 10 and upper bound as 32. So the mid is going to be 21. So we are going to check whether we can split this array m times by using maximum sum as 21. To start calculating the array, if you add 7 plus 2 plus 5, it is going to be 14. And if you add one more 10, it is going to exceed 21. So we are going to fix this as one subarray, and the rest 10 plus 18 gives less than the sum 21. So we are going to keep 10, 8 as another subarray. So now we have split our subarray into 2 within the sum 21. So we can make sure that the maximum sum can either be 21 or less than 21. So in this case, we are going to move our right pointer to this value, and we keep our upper bound as 21 now and lower bound stay the same, and we are going to find a new mid and figure out whether we can do this or split this array with that sum. So now the mid is going to be left plus right by 2, which is 15. So now in this case, we are going to check whether we can split the array into 2 by having maximum sum as 15. The same way, we can split 7 to 5 as one subarray since the sum is 14, which is less than 15. And the next subarray will have only 10 because 10 plus 8 will exceed 15. So 10 as second subarray, and we will be going for one more subarray 8 to fulfill this sum. So in this case it fails because our m is equal to 2. We cannot split our array more than twice. So we clearly know 15 is a lesser sum for this array to be split into 2. So we know our output lies somewhere between 15 and 21. So we are fixing our range, lower bound as 15 and higher bound as 21. Now we are going to find our new mid, which is 18. Now we are going to check whether we can split this array into 2 by having the maximum sum as 18. So now having 7 to 5 in one subarray, because if you add 10 it will become 24, which is higher than 18. So next, if you add 10 plus 18 as one subarray, which is actually equal to our mid value, so we have split our array into 2 by keeping the maximum sum as 18. So now we clearly know our value lies somewhere between 15 and 18. Further, if you find the mid and goes and find the value, it is going to stuck at 18 because that is the output. And the time complexity of this algorithm using binary search is going to be big O of n log k, where n is the length of the given array and k is the mid value or the number between 10 and 32. So now let's see how our code works. So as per binary search template, I'm going to have my default values. So here we assigned our left value as the maximum element given in the array and right value as the sum of the elements given in the array. So this is nothing but the binary search template we have seen in our first video, that is how binary search works, and we are going to use the same template here. In this template, just by updating the upper bound and lower bound values according to the problem statement, and the can split function is going to decide how the logic actually works. So now let's spend some time in writing the code for can split function. So here I have initialized my count to count how many splits we are making the array, and we are adding the numbers given in the array nums, and whenever it exceeds the sum, that is the mid value we pass as the parameter, we are going to add a count, that is we have split the array and we are going to assign a new total from the current element. So as we complete totaling all the elements, we are going to check how many times the array is split. If it is split more than m times, then it is not in our bucket, so we are going to return false. If not, we are going to return true. And in our main function, it is going to check if the value is higher, then we are going to set our upper bound or right pointer to mid. If not, if it is lesser value, then we are going to set our left pointer after mid. So after calculating, our left is going to hold the actual output, so we are going to return left. So let's run. So yes, the solution is accepted and it runs faster than 100% of the solution submitted. So thanks for watching the video. If you like the video, hit like and subscribe and wait for more videos on binary search. Thank you.